Okay guys, so this video is not your exam review video, but I'm just kind of helping you guys out with some extra few topics that I know are kind of a struggle. They were for me, so I'm here to help you this time around. Marita's actually going to be doing your exam review, so this is just to kind of clarify some extra stuff. So in the ventilation section of your outlines, we're kind of on chapter 17 right now. I have a really useful picture for these lung pressures and capacities that are going to be kind of helpful for you guys later. So anything that's a volume is just a volume. That's what it is. And then anything that is a capacity are going to be one or more volumes added together. So like your tidal volume or your residual volume, that's just a volume and that's just a number you're going to have to know. And then your capacity, for instance, your inspiratory capacity, that's your tidal volume, and your inspiratory reserve volume. Those are two volumes added together to make it an inspiratory reserve capacity. So then for these mechanical factors you have next, the elastic recoil is the opposition to stretch or distortion. So in your lungs actually have a recoil inward. So if these are your lungs, they actually want to kind of go in. So your lungs have elastic recoil inward. So then this is the force. Again, if you're having recoil inward, it's going to be the one that opposes lung expansion. So good recoil is needed for expiration. And that's for your lungs. So then for your chest wall, which would be kind of like this, your chest wall is actually going to have recoil outward. So your chest wall is going to kind of want to pop out. So this chest wall has outward recoil. So now that you kind of know the general direction, so lungs has elastic recoil inward and chest wall has outward recoil, you have to kind of move on to like the relationship between volumes and pressures. So definitely you have to know that volume and pressure just in general are inversely related. So if your pressure goes up, that means your volume has to be going down, and if your volume is increasing, then your pressure is going down. So then when you get into kind of determining whether it's inspiration or expiration, you can kind of determine whether you're inhaling or exhaling based off of those pressures, and then also you can do it just based off of the little greater than or less than sign. So then when you do, for example, starting at 0, I guess, if you have the pressure in the alveoli, if those are equal to pressure in the atmosphere, that means you have no air movement and you're not breathing. So basically this will happen when you're either holding your breath or it'll be in between breathing cycles. So the reason you have inspiration and expiration is because you breathe in and then you have a pause where the pressures are equal, and then you breathe out to equalize it. So when you have alveolar pressure greater than the atmospheric pressure, so this is pointing this way, that means you're going to have air going from the alveoli basically into the atmosphere, so that's going to be expiration or exhaling. And then on the other side, when you have alveolar pressure is less than atmospheric pressure, you're pointing this way, so it means the air is going to go in to your alveoli, so that means you're doing inspiration or inhaling. So then another important thing to know is that your interpleural pressure is always going to be negative. And that comes into later for this picture that I have for your ventilation pressures. So anything that's a transmural pressure, that includes your your intrapleural pressure, so the pressure in between your, basically your intrapleural cavity. So the pressure in that cavity is always going to be negative. So then when you get into these, you kind of have, so your transpulmonary pressure, your chest wall pressure, and then your respiratory system pressure. So transpulmonary pressure is going to be abbreviated like this. And so this is going to be the pressure holding your lungs open. And then it opposes elastic recoil of the lungs. So basically it keeps it open because your lungs have recoil inward. And then it prevents your lung collapse. So the little formula for this one is going to be transpulmonary pressure is equal to alveolar pressure minus your intrapleural pressure, which remember this one's always negative. So then for your chest wall pressure is going to be abbreviated like this. And your chest wall pressure, remember your chest wall has recoil outward, so it is opposing the elastic recoil of the chest wall, and it prevents excessive expansion. So it's the pressure that holds your chest wall in. And this formula for this one is your chest wall pressure is equal to your intrapleural pressure minus your atmospheric pressure. And I'm going to draw the picture after this. It's going to be really helpful. At least it was for me. And then your respiratory system pressure is abbreviated like this. And it's basically just the driving force for your airflow. And that one is, so respiratory system pressure is equal to basically all the way inside and all the way outside. So your alveolar pressure minus your atmospheric pressure. So those are really important to know, and just kind of what they are and what they include in their little formulas. So now I'm going to draw this picture. One of the other physio mentors when I took this class last semester drew this picture, and it was really helpful to me. So here we have the chest wall. And obviously this isn't going to be anything anatomically or physiologically correct, but it's just so we can kind of see what's going on. So this is going to be your chest wall. And then you have on the inside of that, you have your lungs. Okay, so like we said before, so your chest wall has recoil outward, and then your lungs has recoil inward. So then obviously these are your lungs. So this space right here is your intrapleural space or cavity. And so basically these transmural pressures are pressures across the lungs, the wall of the lungs, and the chest wall, and that's kind of what makes them important for breathing. So then when you have your alveolar pressure is going to be in here. And then your intrapleural pressure is going to be in the intrapleural space. And then your atmospheric pressure is going to be out here. So then the differences between all these is what's going to give you your transpulmonary pressure, chest wall pressure, and then respiratory system pressure. So your transpulmonary pressure is going to be basically just the difference between these two right here. And then your chest wall pressure is going to be the difference between these two. And then the difference between basically all the way inside and all the way outside. So alveolar pressure minus atmospheric pressure is going to be your pressure in the respiratory system.